Alright everyone, welcome back to Cody's Lab. So my algae panels are being worked on again, and I'm just about ready to fill up the second iteration of the design with algae. The only problem is, this is currently all the algae I have. This is my spirulina culture, which is currently at 3 quarts. And I need it to be about 20 gallons. So to get it to be 20 gallons, I need to make more culture medium. I promised to do a video on this at some point, and here we are. So, let me talk about how originally I started with algae. I started using plant food, because this has got all of the micronutrients the algae could ever want. The only problem is, it is very common for plant food like this to contain algaecides. If I added this to my algae right now, it would kill it. Same thing with this hydroponic nutrient. It's got algaecide in there. It's got all of the micronutrients and everything, but it's got that one extra ingredient which kills bacteria, and algae is a cyanobacteria. This stuff is not going to work. Now, of course, you can buy nutrients special for growing algae, which doesn't contain the algaecides, but I like to make it myself so I know exactly what's in it. I have everything on the table here, which I need. I've got my recipe, which we can have a look at. So this is roughly based off of Zaruch's media, which is a recipe that I found in the Egyptian Journal of Aquatic Research, accessed just via Google. And I've made some adjustments. I've kind of rounded some of the values. You know, it's not super sensitive. It could be plus or minus 50% on most of these, and the algae doesn't notice. And I've also added more of the trace elements. And to get the values for those, I just looked on a vitamin bottle to get kind of an idea of what the ratio should be. I mean, it's probably different for algae and humans, but like I said, the algae is pretty adaptable. Now you might notice that I have converted everything so that I'm showing the weight in grams per liter of finished media of each individual element. Now, of course, I'm not going to be throwing in a chunk of pure phosphorus. That wouldn't work. The algae wouldn't be able to use that. It'd probably kill the algae. Instead, you're going to be working with stuff like ammonium phosphate, or I think I actually have monopotassium phosphate. So you need to figure out how much of the element is in your substance. For this, it gives you the NPK value, which is quite handy because this tells you that the phosphorus value is 52% of the weight. The ammonium phosphate is, I don't have that on here, but it's 20% by weight phosphorus. So, in order to make 0.1 grams per liter, I need to add 0.5 grams of ammonium phosphate per liter. Now, when you're doing the calculations, something you need to keep in mind is the fact that some of the chemicals contain more than one element. Ammonium phosphate, for instance, contains the ammonium ion, which has nitrogen. So adding this is going to add a little bit of nitrogen as well. And as a result, maybe you would add a little bit less of the sodium nitrate when you're adding to try to get your nitrogen. And if you're using the potassium phosphate, this doesn't have nitrogen, but it does have potassium. So you would end up using a little bit less of the potassium sulfate, in my case. You just have to do all those calculations. It's a bit of work. It's basically like doing your chemistry homework. I've already done it all, so there's the values. I'm going to go through and weigh them out now. I'm actually going to be making 100 liters of solution, or at least the solution's concentrate. So I need to weigh out 100 times these values. So for example, with the baking soda, that's going to be about 1.7 kilograms worth, which I hope I have enough. I think I do. So So I'm going to do most of that off camera. I'm also going to do them in like 2 groups, the bulk nutrients and the trace nutrients, because the dilution ratio is going to be different. So let me get to that. Hopefully in the next cut I'll have this all arranged nice and neat and you can see the actual amounts I'm using. All right, so I got it all weighed out. That is a lot of baking soda. I don't actually think I'm going to add this to the concentrate because I would need about 17 liters of water to dissolve all this, and I was kind of hoping for 2 liters, so I'll end up adding the baking soda separately. That's actually better because that means that the solution can be used for other algae, not just spirulina. Spirulina likes the alkaline environment that this gives. So anyway, there's the sodium nitrate, 250 grams worth, which maybe I shouldn't try to pick up one-handed. I'm just gonna load these into a pot. So there's the potassium sulfate, sodium chloride, and then I'll dissolve these in hot water. There's the ammonium phosphate, calcium nitrate, magnesium sulfate, and I'm actually adding the iron to the bulk nutrient because iron is just, you need so much of it. And this is iron chelate, which is even more volume because there's so little iron in the molecule. And the reason I'm using iron chelate instead of, say, ferrous sulfate is because in the alkaline environment, the ferrous salts are easily oxidized to the ferric salts, which the algae can't use. If the salt gets into the algae before it's oxidized, then the algae can actually use its own antioxidants to keep it from oxidizing. But while it's in storage, it will oxidize, and then once it's oxidized, the algae can't use it. So anyway, let's add that in. Iron chelate is essentially iron 2 salt with EDTA. This is an antioxidant, a chelating agent, which binds to the iron and protects it from oxidation. Maybe at some point I'll do a video on making this stuff. Okay. I'm going to add just under 2 liters of water. And now I'm going to light a fire under it and bring it to a boil. This will kill any bacteria that happens to be living on the salts and also help the stuff dissolve. Okay, well that cools. I'll work on the trace nutrient solution. I've now come to the silicon, which is going to be in the form of amorphous silicon dioxide. For that I'm going to be using some desiccant gel, which I will have to crush up using this pestle and mortar. Okay, that could have gone better. Let's drop that on the scale. Perfect. Some of these trace elements, such as the vanadium, selenium, chrome, cobalt, they require such small amounts that it's difficult to weigh them out accurately. So what I'm doing is I'm going to take an amount that I can weigh out. So this is going to be 114 milligrams. All right, just like that. I'm going to transfer this into a little bottle. There. I'm going to add a milliliter of water to dissolve it. And now I have a solution containing approximately 50 milligrams vanadium per milliliter. So now if I take 1 drop of this, assuming a drop is 1/20th of a milliliter, then I should have 2.5 milligrams of vanadium. So it's a way to measure it. And here's the trace elements weighed out. So I got the boron in the form of boric acid, manganese as manganese sulfate, some copper sulfate, amorphous silica, zinc sulfate, some sodium iodide, which I forget is hydroscopic. Okay. There's some sodium molybdenate for molybdenum. You don't need very much molybdenum. Now, these that I have in the bottles, which are in a solution, I just need 1 drop of each. So here's the cobalt. Bloop. I'll clean this. I'll get those others in off camera. I'm also going to be adding some calcium fluoride. The algae doesn't need this, but I do. And if I'm going to be eating the algae, I'd like there to be a little bit of fluoride. And finally, me adding some EDTA. This is the antioxidant chelating agent, which will keep the elements from being oxidized to an unusable form. There we go. Add some distilled water. Now, this won't fully dissolve. Silica, for instance, is not going to dissolve. So it's going to be kind of a milky solution. It'll settle out, but before using it, you want to shake it up to fully mix it so you can get all the little particles into the final solution. Okay. Give that a good mix. And I'm going to pour it into this plastic bottle, which is 1 liter in volume. And finish filling it with water. And there's the trace element solution finished. Now it actually looks pretty clear until you get it in the light. Yeah, the silica is floating around in there, probably along with the fluoride. This one that I made about a year ago, maybe more than a year, I included the iron and I didn't have the EDTA. Without the antioxidant, it oxidized. And you can see it's not blue, which means the copper, probably also the cobalt, has also oxidized and settled out of solution and is unusable. Like even if I shook this up, it's not soluble. It can't be used by the algae. So this is garbage now. Hopefully this one will be better. So one thing about this is buying all these chemicals is fairly expensive. And especially for like the molybdenum, this is the smallest size I could buy, and I'm never going to use that much, like ever. So it is kind of fairly wasteful to buy, amounts of the ingredients and then use a tiny bit. If you're doing this on your own and you don't want to get too involved, you can grind up multivitamins. The algae can use the nutrients that are in here. The extra vitamins won't hurt too bad. The solution will be a lot more cloudy. There's a lot of calcium and stuff. You might have to add an iron supplement because these generally don't come with iron anymore. And as for the amount, probably about 1 vitamin tablet per pound of algae you plan on growing. I think that's about right. Like I've said multiple times, it doesn't have to be exact. The algae is adaptable. The bulk nutrient solution is now cooled. I'm going to transfer this into a 2-liter bottle and topped off with a little bit of water. So here are my finished solutions, 50 and 1,000 times concentrated. So now if I wanted to make, say, 4 liters of the algae media, I would take 4 milliliters of the concentrated trace element solution, just like that, and 100 milliliters of the bulk nutrient solution. Just like that. Since I want the media for spirulina, and I didn't add it before, I'm going to add 85 grams of baking soda. Now this should fizz like crazy when it hits the liquid. Yes. Just carbon dioxide being released. Now I'm going to add a gallon of water. This will get me close to 4 liters of total volume. And finally, I'm going to sanitize the media by bringing it to a boil. So now, here's my algae culture. I'm going to give it a bit of a stir, and I'm going to pour it through a screen into a pitcher, which is clean. The screen is to remove dead algae and any algae that's too clumpy, just like that. Okay, quite a bit of dead algae in that batch. It's been a while since I've changed it. Now I'm going to pour some of the algae off into a jar, just so I can keep it in case the new media is deadly to the algae for some reason because I messed up. I'll have some that I can restart the culture with. And the rest of it I'll split between these 2 jars, which are freshly cleaned. Jugs. They're jugs. Now that the media we just made is cooled down to room temperature, I'm going to transfer it first into this pitcher, and then I'm going to fill the rest of these jars. Now the reason why I don't just add the algae to a 20-gallon tank of the media is because I've tried that. The algae doesn't like it. For some reason, it doesn't like being diluted. And if it's diluted too much too quickly, it just dies. I don't know why. maybe it just gets lonely. Anyway, and just like that, I've doubled the volume of my algae culture. In a few days, I can do it again. Let's go put these on the bubblers in front of the light, and that'll be it. Hope you enjoyed. I'll see you next time.